Hello students, now in NEET 2017, the question number from 26 to 30. Now the question number 26. Which of following statements are correct? Which of following statements correct? Number 1. Center of mass of a body. Center of mass of a body always coincides with center of gravity of the body. Center of gravity of the body. Second, center of mass of the body. Center of mass of the body is the point at which total gravitation torque on the body is 0. On the body is 0. Second. Third, a couple on a body produces both translational and rotational motion in body. And now fourth is mechanical advantage greater than 1. Greater than 1 means that small effort can be used to lift a large body. These are the options. center of mass of the body always coincides with the center of gravity of the body? This is not so. Because center of mass and center of gravity of a body coincides only for the regular bodies, but for all kinds of bodies this is not true. So first option is wrong. Second, center of mass of the body is the point at which the total gravitational torque on the body is 0. This is right. Because the gravitational torque means that if you are taking the torque about the center of mass, that we know that this m1 r1 plus m2 r2, that this is all, the sum of these is equal to 0. So this option is correct. Third, a couple on the body produces both translational and rotational motion in the body. This is wrong, because a couple always produces a rotational motion only, no translational motion. So the option third is wrong. And now fourth, mechanical advantage greater than 1 means that a small effort can be used to lift a large body. This is correct. Whenever mechanical advantage is more than 1, then by the application of a small force, a large amount can be lifted. So this is what the meaning of mechanical advantage more than 1. So this is right one. So our options correct to this one is now second and the fourth. Now here the options are given. This is now your A. This is B. This is C. And this is D. Now options are B and D, B and D. Second option is A and B, A and B. Third is B and C. And now fourth one is your C and D. C and D. So I told you just now that the right answer is your B and D. B and D. Now first one. This is now first one. Now question number 27. A Carnot engine having efficiency of 1 by 10. A Carnot engine having efficiency of 1 by 10 as heat engine, is used as a refrigerator. If work done on the system is 10 joule, the amount of energy absorbed, the amount of energy absorbed from reservoir at lower temperature. From reservoir at lower temperature is first 1 joule, second 90 joule, 10 joule, no, this is 90 joule, and third is 99 joule, and fourth is 100 joule. Now the solution to this question: you are given a Carnot engine which is used first as the heat engine, then its efficiency is 1 by 10. So eta is given 1 by 10. Now then this Carnot engine is used as a refrigerator. In that case, the coefficient of performance this beta is equal to 1 minus eta upon eta. This is not relationship. So this you can have this beta is equal to 1 minus 1 by 10 upon 1 by 10. So this beta will come out to be 9. Beta equal to 9. Now then we know beta is equal to Q2 upon W. Amount of heat absorbed from the reservoir at low temperature to the work done on the system. So this we use. Then beta is equal to 9. Q2 that you have to find. W is equal to 10. So this will give you this Q2 equal to 90 joule. So much amount of heat will be absorbed by the from the reservoir at low temperature. So our option is 90 joule. That is now your second. This is now second option. So first you are given the Carnot engine used as a heat engine. Then this is the coefficient of efficiency. So this is 1 by 10. Then find the coefficient of performance when this is used as the refrigerator. And then apply the formula beta equal to Q2 upon W. Put the value of W, that is 10 joule given here. And then you will find this Q2. And now question number 28. 28. If Q1 and Q2 be the apparent angles, if theta 1 and theta 2 are be the apparent angles of dip, observed in two are observed in two vertical planes at right angles to each other. At right angles to each other, then the true angle true angle of dip theta is given by, now the first option is cot square theta equal to cot square theta 1 plus cot square theta 2, and second option tan square theta equal to tan square theta 1 plus tan square theta 2. Now two more options. Now option your third. Third is cot square theta equal to cot square theta 1 minus cot square theta 2, and fourth option tan square theta is equal to tan square theta 1 minus tan square theta 2. So those relation cannot be trapped here, but the first option is the right one. Then when we are given the two apparent dip angles at the in the vertical planes which are right angle at the right angle to each other, then the true value of the dip angle is given by cot square theta equal to cot square theta 1 plus cot square theta 2. So our option is cot square theta equal to cot square theta 1 plus cot square theta. So our answer is first. So now first answer. Now question number 29. An arrangement of three parallel straight wires parallel straight wires placed perpendicular to the plane, placed perpendicular to the plane of paper, plane of paper carrying same current I, carrying same current I along the same direction, along the same direction as shown in figure, as shown in figure. The magnitude of force point length magnitude of force point length on the middle wire B, on the middle by B is given by now options are first here the figure is given that these are the this is A, this is B, this is C, and the distance, this is the distance D, this is also the distance D. This is the given figure, and now option is mu naught I square upon 2 pi D. Second, 2 mu naught I square upon pi D. And third is under root 2 mu naught I square upon pi D. Fourth is mu naught I square upon root 2 pi D. These are the options. Now the solution to this question. You are given the three wires. This is now wire A. This is now wire B. This is now wire C. This is so much. This is A, this is B, and this is C. The distance between them is given to you D. This is now D, and this is also now D. So these wires are perpendicular to the plane of the paper. It means that if I take this blackboard, then they are perpendicular to this blackboard. So this is now like this. As I hold this pen, which is perpendicular to the plane of this whiteboard. Similarly this and similarly this. Since the currents in all three wires are in the same direction, and we know then this is the situation, so then they will attract to each other. So this B will attract to this A, and B will also attract to this C. So now here the force is, this is now force F1 and this is now force F2. Both of them will attract to each one. So now force on force. Per unit length. F, this is given your mu naught upon 4 pi into 2 I1 I2 upon R square. This is now formula. And here what we have that I1 and I2 are the same and R equal to D. Here I1 equal to I2 equal to I, and this R is equal to D. So what we have, the force on B due to A, force on B due to A. So this is now suppose the force F1. Force on B due to A, this is now suppose F1 equal to mu naught upon 4 pi into 2 I square upon D. So this will cancel by this one 2. So this will be your F1 equal to mu naught I square upon 2 pi d. Now force on B due to C, this F2, this is also this mu naught I square upon 2 pi d. Now resultant force will be what? That this will be the resultant force. If you just complete to this one, then this will represent the resultant force. This is the resultant force. This we have to find the resultant force. Now you see that this F1 and F2 are equal. F1 equal to F2. Resultant force on B. This F equal to square root of F1 square plus F2. Both forces are equal. So we can write this F equal to square root of 2 into F1. Or this F equal to square root of 2. This is your mu naught I square upon 2 pi d. So now this will cancel by root 2. And you will have this F equal to mu naught I square upon root 2 pi d. This is the right answer. So our correct is this fourth. Now we have the answer. So first you remember that when the wires are parallel straight and carrying the current in the same direction, then they attract to each other. This is the force of attraction that is shown by this wire on this B, and this is now force due to C on the wire B. And both are at the right angle and forces are equal. F1 and F2 are equal. So this is now F1 square plus F2 square. So F equal to square root of 2. F1 or F2, no meaning. Then you put the value, just simplify. You will get the answer. So this is how to find the answer to this one. And now question number 30. And 30. Two astronauts two astronauts are floating in gravitational free space. Gravitational free space after having lost contact with their spaceship. Contact with their spaceship. The two will. Now the options. First option is keep floating at same distance. Keep floating at same distance between them. Second, move towards each other. Move towards each other. We know that in gravitational free space there is no gravitation by the planets, so they are free to move or free to float in the space. Now third option is move away from each other. And fourth option is will become stationary. Become stationary. So what we have, that we are having the two astronauts are floating in the gravitational free space after having lost the contact with their spaceship. Now then, these are the two astronauts. They have lost the contact with their spaceship, and now they are in gravitational free space. It means that they are in the condition of weightlessness. So the other planet, the gravitational force because of the planets is zero, but they have their own gravitational field. So because of that, they will attract to each other and they will come towards each other. They will move towards each other. Solution is what? The astronauts are in weightlessness condition. Weightless, they will float at the same height, but they will attract to each other. The astronauts will attract each other because of their own gravitational fields. So they will move towards each other. It means that distance between them will go on decreasing. So what will be, this is now suppose one is space astronaut, this is another is astronaut. So this is an astronaut A, this is an astronaut B. They are in free space, then they will float at the same height, but because of their gravity, this will attract to this one and this will attract to this one. This is now force of attraction. So because of this attraction, they will come close to each other. They will come close to each other. Close to each other. A and B. So it means that our the first the option is that move towards each other. This is now right one option. So our answer is your second. So these are the 5 questions of NEET 2017. The questions are from 26 to 30. Thank you very much.